I'm Anil Kumar. In this video, we'll discuss few questions related with prime factorization concept. We'll slowly build the concept so that even students going to junior school level will understand a bit of it, and will develop it to the stage that high school students will also find it interesting to understand few concepts which can help them get into good universities. Now, encouraged with your great response, we are actually starting a website called globalmathinstitute.com. At present on YouTube, we have around 12,000 free videos, 40,000 subscribers, and these videos are being watched in more than 80 countries. Thanks for excellent response. Your suggestions and active participation has made it possible. Now let's answer the questions one by one. The 5 questions here are: list all factors of 24. Question number 2, how many factors will 60 have? Question 3, write 60 as product of prime numbers. Question 4, n equals to 2 cubed times 3 squared times 5. How many factors will n have? And question number 5 is a tricky question. How many even factors are possible for a number whose prime factorization is 2 squared times 3 squared times 5 times 4 times 7? 4 choices are given to you. Now that kind of question could come in Waterloo exam also. Okay, so let's begin and understand the basic concept of finding factors. So the first question here is: list all factors of 24. So we'll kind of make a rainbow to list all the factors of 24. See how. Let us say, let's begin with 1 itself. So we know 1 times 24 is 24, correct? 1 times 24 is 24. How about 2? Now 2 times 12 is 24. And 3 times 8 is 24. How about 4? 4 times 6 is 24, right? And then it is 6 times 4, so 8 reverses. So what we see here is that we kind of get a rainbow where we can connect these, right? So 1 times 2 is 24, and then we know that 2 times 12 is 24, and then we have 3 times 8 as 24, and then we have 4 times 6 as 24, right? So these are all the factors. If you list like this, you're not going to miss any. So let me write down all the factors of 24. So factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. There are 1, 2, 3, 4, 5, 6, 7, 8 factors of 24. Now let's move on to question number 2, which is: how many factors will 60 have? Now the question is not to list the factors, but only to find number of factors, correct? Now there are many methods to do it, but at present we'll follow the method which we just learned. So we'll just write factors of 60. So we know 1 times 60 is 60, and we know 2 times 30 is 60. We can still divide this by 2. So we get 4 times 15 as 60. In between we missed 3, right? I should have written 3 times 20 is also 60. Can we divide by 5? Yes, of course. So we get 5 times 12 as 60. And also we know lesser space. So let me expand here. 6 times 10 is 60. And then what? 7, 8. Now 8 is not, so 8 times it can go, right? So 8 times it will not go. So 9, 10, 10 times 6, right? So we kind of reverse back, correct? So I could have squeezed in 6 times 10 there itself. So what we get here is kind of a rainbow, as you saw earlier, where these numbers kind of connect, correct? and they give you product of 60, right? Also this, correct? So you can now count how many factors are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 factors of 60. Is that clear? So let's move on and take up the next question, which is write 60 as product of prime numbers. Now, when we want to write a number as product of prime numbers, what are we trying to do? We are trying to find prime factors only, right? So we call this process as prime factorization. Now let's see how to do prime factorization. So we'll begin with the number 60 and let's write down what could be the factors of 60. Well, we could write 10 times 6 is 60, for example. Then 10 could be split as product of two numbers, which is 2 and 5, correct? And 6 could be written as 2 times 3. So what you notice here is that we have all the prime numbers. And now we can write 60 as equal to 2 times this 2 I'm writing first, and then let's write down 5 and 3. Well, no need to order them in particular way, but it is better to order, right? So we have written 60 as product of prime numbers. So that is what is required. At times, we also write it in short form. So we write 2 square times, you could write 3 times 5. That gives you an idea how to write a number as product of prime numbers, correct? Now let's go to question number 4. It says that n is equals to 2 cubed times 3 square times 5. How many factors will n have? Now, how to answer this question? Now, that is tricky. To answer this question, let me get back to question number 3 itself, and then we'll come back to question number 4. Now, actually, we have a similar situation here, right? You will notice that 60 has been written with these combinations, and prior to this, we actually found the number of factors, and we found that the number of factors for 60 are 12, correct? So we know one thing for sure, that number of factors of 60 are 12. So we have 12 factors. Now, how do we get this answer from prime factorization? This is what we need to understand. Now, that's the critical part of our video. Now, the idea is that if you have 2 square, that means there are 2 2's. Then you could choose one of the 2's, you could choose both 2's, or you may not take any 2, right? So we have 3 choices for 2's, right? So we have 3 choices for 2. As far as 3 is concerned, we may take a 3 or we may not take a 3 to find factors. So there are 2 choices. And for 5, we again have 2 choices. You will notice that 3 times 2 times 2 gives us the magic number 12. You get an idea. So the formula is kind of before you. So once we have the prime factorization, we can find the number very easily, right? So that's the whole concept. So in this particular case, we are given n as 2 cubed times 3 square times 5. We need to find how many factors will n have. Now, as far as 2's are concerned, we may take a 2, or we may take 1 2, 2 2, or 3 2. So we have 4 choices, correct? So for 2's, we have 4 choices. As far as 3's are concerned, since there are 2 3 factors, we have 3 choices. And with 5's, we may take a 5 or we may not take a 5. So we have 2 choices to make. So total number of factors will be product of these, which is going to be 4 times 3, 12, 12 times 2, 24. So 24 is the total number of factors that n will have. You get an idea, right? So that is how from the prime factorization we get our result. Now here is a formula for you. Formula is like this. For any number n, if we have, let's say these are the prime numbers a, b, c and d, right? And let's say there are PAs, QBs, RCs and SDs. In that case, our answer is that number of factors will be add 1 to each and multiply. Do you understand? So add one exponent to each and then multiply. If the series is extended, you extend it. So that is the kind of formula which you can work with. Now here is an alternate approach. Now this number is not that big, so what you could also do is you could find the number first, right? So the number here is 2 cube means 8 times 3 square is 9 times 5. So that is the number, right? So it is 40 times 9 or 360 is your number. So what you could do is you could make a rainbow and find all possible factors. Well, that will be a good exercise to verify that you get 24 or not, right? And that will give you the result as 24. Correct? So that is the last option. Now, we are moving on to high school students, and at times this could be a test question for you in papers like SAT, right? Or even in Waterloo. I have seen this kind of test questions. So the question for you now is, how many even factors are possible for a number whose prime factorization is 2 square times 3 square times 5 times 7? Remember, we are looking for only even factors. So you can pause the video, answer the question, and then look into my suggestions. Now to find even factors, what we are going to find is, we'll actually first calculate total number of factors, right? Total number of factors. And then we can calculate not even. And then we'll subtract and get even factors. So that is the hint. Now you can follow this hint, answer, and then look into my suggestions. Now here is how we can find total number of factors. Total number of factors are, there are 2 2s, so that means it gives us 3 combinations. Multiplied by, there are 2 3s, that gives us 3 combinations, 2 plus 1. 1 5, we may take a 5, we may not take a 5, that means 2 combinations. For 7 also, there are 2 combinations. So total number of combinations are 3 times 3 times 2 times 2, 9 times 4, which is 36. Is that clear? Not even means that you're only considering these numbers, not 2. Okay, so here the combinations are these number of combinations. That is, you may take 3, you may not take 3, or you may take 2 3s. So 3 combinations for 3. May not take 5 or take 5, 2 combinations. May not take 7, may take 7, 2 combinations. So here you get 4 times 3 as 12. So even are those in which 2 is not a factor. Do you understand? Not even, correct? So that means 2 is not a factor. That means 2 is a factor. So take away not a factor, 2 is a factor, right? Always. So it is 36 minus 12. That gives you 6 minus 2 as 4 and 3 minus 1 as 2. So 24 is the answer. Do you get it? Correct? So you have to now use 2 definitely as a factor. So this is one way of doing it. So I hope you find it interesting and useful. So prime factorization, which is a topic studied in middle school, can be very useful for high school students, especially if they are seeking admission to good universities. And I hope this video gives you a good idea of answering such questions. Feel free to write your comments and your suggestions. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.